a squared plus 3a minus 5. This is an example of a polynomial, in which case it has 3 terms and we can call it a trinomial. So each term here, finding the sum of all the terms, that's what a polynomial is. Now the degree of a polynomial in one variable is the highest degree that that variable is raised. In this case is 2. Now if we're talking about just a single term, this is a monomial. If we have 2 terms in our polynomial, this is called a binomial. In our whole example here, we have 1, 2, 3 terms, and therefore it's called a trinomial. So moving on to multiplication of polynomials. In this section, we are going to discuss 2 different methods in order to multiply polynomials. Our first method is to multiply vertically, and this is very similar to long multiplication with whole numbers. So we can take this polynomial. We have the quantity 5 minus 3t times the quantity 4 plus 2t. So we're multiplying 2 binomials here. Let's take this first binomial and we'll write it here, 5 minus 3t. And then below it, to multiply vertically, we're going to write our second binomial, which is 4 plus 2t. And we're going to multiply these 2 polynomials in order to find our answer. And by doing that, we multiply each term in the first polynomial by each term in the second polynomial. So we'll do it this way. We'll do 4 times negative 3t, which is negative 12t. And then 4 times 5 is 20. And then the second term, 2t times negative 3t gives us negative 6t squared. And then 2t times 5t is 10t. Now notice, as I went through and found those initial products, I lined up my terms in a similar way so that we can add these together and we're adding similar terms. It makes the math easier. So we can bring down our 20, and then negative 12t plus 10t is negative 2t, and then minus 6t squared. So here is our product when we multiply these 2 binomials. Our second method is called FOIL, and this is actually an acronym which stands for first, outside, inside, and last. And that represents the process by which we're going to multiply our polynomials. So I've written here this product. It's the same one that we just worked. So we have 5 minus 3t times the quantity 4 plus 2t. And you'll see when we use FOIL, we're going to end up with the same product. We're just going to go about it a little different way. So using this acronym, first, outside, inside, last. Let's multiply our first terms first. So we have 5 is our first term in our first polynomial, and 4 is our first term in our second polynomial. So 5 times 4 is 20. Then we have outside, which are the terms on the outside of our product here. So we have 5 times 2t, which gives us 10t. Then we have I, which stands for inside, which are these 2 terms on the inside of our product here. Negative 3t times 4, which is negative 12t. And then last is our last. So we have the negative 3t times 2t, which gives us negative 6t squared. Now all we have to do is combine similar terms. We have 2 here in the middle, so we have 20 plus 10t minus 12t is, here we're going to change this to a negative 2t, and then negative 6t squared finishes it up. So this is our product when we multiply these 2 polynomials by our method of FOIL. So as you can see, our answers are the same even though we use 2 different methods. Let's move on and we'll talk about some special products. Our first special product is the square of 2 binomials. So when you're squaring binomials, we found that the resulting product follows this rule. So let's say we need to square a plus b. We get a squared, where a is the first term squared, plus twice the product of our first term and our second term, AB, plus b squared, where b, again, is our second term. Now, if you change the operation sign inside this quantity here from an addition sign to a subtraction sign, then the resulting product is a squared minus 2ab plus b squared. So let's try an example. Suppose we're asked to find the square of 5x plus 2y. So our first term, a, is 5x, and our second term is 2y, so b is equal to 2y. All we need to do is plug these values into this rule here to find our final product. So a squared is 5x squared plus 2ab, so we have 2 times 5x times 2y, plus b squared, which is 2y squared. So now let's simplify this. This then is equal to 5 squared, 25. Distribute this power here over to the x as well, so we have x squared, plus 2 times 5x times 2y. If we're using our associative property, we can multiply 2 times 5 times 2, which gives us 20, and then x times y here. And then we have, distributing our power over to the 2 is 4, and on the y is y squared. So here is our final product when we're asked to find the square of 5x plus 2y squared. Now you also find, and you can check this yourself, if you were to write this out as 5x plus 2y times 5x plus 2y, this is the same as this here, 5x plus 2y squared. Now, if you were to use the two methods that you've learned previously, either the vertical method or FOIL, and find the product, you would get this same answer. So now let's discuss our last special product, which is the difference of squares. Our second special product is the difference of two squares. And this is found when you multiply two binomials that only differ in the sign. So a minus b times the quantity a plus b. We have two different operation signs here. And when you find this product, you get a squared minus b squared, which is the difference of two squares. So let's try an example. Suppose we're asked to multiply 2a plus 3b and 2a minus 3b. So as you can see, these are two binomials that only differ in their operation symbols. But first, before we apply this rule, let's multiply them out going a long way using FOIL and see what we get. So suppose we have 2a plus 3b times 2a minus 3b. So using FOIL, F-O-I-L, we're going to go through our first terms and find the product of those first. So we have 2a times 2a, which is 4a squared. Then we have our outside terms, 2a times negative 3b, which is negative 6ab. And we have our inside terms, which is 3b times 2a, which is positive 6ab. Then we have our last terms, 3b times negative 3b, which is negative 9b squared. So then if we were to simplify this, we're going to combine similar terms, which we have these two in the middle. So we have 4a squared. Now we have negative 6ab plus positive 6ab, so that's going to cancel, just leave us with 0. And then we're left with negative 9b squared. So again, simplifying this gives us 4a squared minus 9b squared. Look at that. We have a difference of two squares. So if we were to go back and use our rule on this example here, our first term, a, is equal to 2a, and our second term is equal to 3b. B is equal to 3b. We plug these values into this rule a squared minus b squared. So we have a squared 2a squared minus b squared, which is 3b squared. Then if we simplify this, let's distribute our powers. So 2 squared is 4, and then a squared minus 2 over to the 3, which is 3 squared, which is 9, and then b squared. We end up with the exact same product. So this is a difference of 2 squares when you multiply two binomials that only differ in the operation symbols. So pay attention to these products, special attention, because when you go through and work in your next section, you're going to be deconstructing these products in order to find the factors. And so becoming familiar with this process now will help you in the long run.